Okay, so let's start another set of tutorials on microwave engineering, and specifically, we're going to focus on something called S parameters. S parameters are very important because it actually tells me how much power is being reflected back or how much power is being incident at, and this is a very important parameter that we use in microwave engineering, and specifically to determine um, uh, how much power is being reflected back into my system, and if due to mismatch of the load. So let's briefly define what that is. Reflected wave over incident wave, and specifically we are focusing on voltages. How much power is being reflected back into my system, given how much power is being incident into my system, into my circuit, into my microwave circuit, or even in a normal electrical circuit at lower frequencies. So let's look at this particular diagram that describes that. Let's say I have a generator, and let's recall something from basic electrical engineering, which is known as maximum power transfer theorem, which says that if I have a source impedance and if I have a load impedance, if both of them are equal to each other, then I'll have a maximum power transfer. Whatever I'm sending from one end, my load will absorb this entirely. But if I have a mismatch in my load impedance, given since I'm using a generator to represent that this side of my circuit, um, then I'll have then I won't have maximum power transfer. So let me give you an example of this. So here in this circuit, I'm representing ZS as being a source impedance. This is my generator. Let's say your function generator or your device that is generating your AC signal. And this is my load, and this is a transmission line or a piece of wire that is connecting my load to your source, which is your generator. So normally when you go to your labs and when you see these test equipment, you see there's a rating of 50 ohms, which is there. 50 ohms actually represent the source impedance of that function generator. And so if I have a load that is not 50 ohms, then definitely there is going to be a mismatch and I won't see a maximum power transfer. And in basic, in lower frequencies we call that maximum power transfer, but at higher frequencies we are actually looking at it in terms of reflected voltage. So let's say you supply 10 volts, and due to mismatch of the load you receive 9 volts. Where is that 1 volt gone? I mean, that 1 volt is being reflected back into my system, which is being reflected back into my system. And at lower frequencies we don't care, but at higher frequency that is quite worrying to us, and we need to learn how to solve this. And in order for me to visualize how much power is being reflected back, uh, the measurement tool or the analysis tool that we use, it's known as S parameters. So scattering, S for scattering parameters, so which actually tells me how much voltage is being scattered. So here's the basic matrix of that. So let's get familiar with the nomenclature that we use in microwave engineering. So for voltage which is being reflected back into my system, which means which is traveling back from my load in this direction, which is traveling from my load to my source, is given in terms of negative, and whatever is being incident at is being represented with positive sign. So positive and negative, which is being reflected back. Um, we can also visualize this using vector network analyzer, which actually tells me a better picture of this, and we can also do it mathematically using S parameters. There are other parameters we also use. We're going to start off with S parameters. I have a couple of microwave devices I just want to show. So for example, if you were to look at this particular diagram, this diagram represents a scattering parameter of a circuit that has two ports. One, these subscript actually represent number of ports. So this network, this device, whatever that dot is, device under test, it has two ports, 1 and 2. So if you were to look at this antenna has a single port. So we are only interested in single port analysis of this. How much, when I input some voltage in it, due to the mismatch here, how much voltage is being reflected back? All right. So S parameter is what? Whatever the voltage that I am giving into my port, due to mismatch of that. Now mismatch is going to be between what and what device? The mismatch for this is going to be the source that I'm using to provide power. So if that source, normally the universal or the industry standard is 50 ohms, if this connector is not matched with 50 ohms of my source, because sources nowadays are usually 50 ohms, so if the impedance of this guy is not 50 ohm or 75 ohm or whatever it is, then I'll have some reflected voltage which is being reflected back into my system. So that is being reflected by V1 plus. How much is being incident at? V1 minus, due to the mismatch of the impedances, how much is being reflected back into my source. All right. So this is a single port device which is representing this. This is just a connector just to show how many ports are there, just to get familiar with the terminology. It has two ports. You have an input port and an output port. It's just a connector, male to male SMA connector that has this port and this port. So you can connect it however you want. So it has two port. So let's say, okay, this is connect to my uh, amplifier like this. I'll come back to it. Then this is another device. This is actually an amplifier by mini circuit. It's a microwave amplifier. So as you can see here, it says input and it has a gain of positive 20 dBm. So my input, whatever the signal that I'm trying to amplify, so I have an input signal that is coming in, all right, and then this output would give me an amplified signal of it. So now this is a two-port network. So let's visualize this with this diagram. So I have an input, let's say this is connected to my function generator. So I'm providing power. So if there's a match here on this port, so this is going to be represented with V1 plus, that how much is being incident into port number one. And if there is a mismatch, how much voltage is being reflected back into my port number one. All right, so far so good. So this is V1 plus, whatever is being incident, and V1 minus is representing how much voltage which is being reflected back into my system. All right, so now this is an output. So let's say at the output, I have my antenna which is connected to it. Let's call this, here's my antenna. Okay, here's my antenna. Let's say my antenna is connected to it. Now, how come? So this is port 2. So how much voltage is at this particular port due to mismatch of it? How much voltage is being incident at, and how much is being reflected back into my system? This is what that is. Okay, so V2, how much voltage is being reflected back into my system, that is given by V2 minus, and how much voltage is being incident, how much voltage this guy is providing to this particular antenna. So that's the idea behind it. So if I'm looking at, so for this, S parameter is going to be S11 from port 1 to port 1, and S22 is going to be from port 2 to port 2. Then of course there's going to be S12 and S21. We're going to look at it in a little bit different, little bit later. Okay, so here's an idea. So this is a two-port device. This is an amplifier. We can also do an analysis, and we can also visualize using a two-port vector network analyzer to see the S parameter, S11, S22. Normally these things are matched. Normally S11 and S22 are exactly the same, but there's a difference of S12 and S21. We're gonna explain this a little bit later. Okay, now here's a three-port device. This is actually a mixer. All right, so this is a local. So one port is your LO, one is IF, and one is RF. So here at your LO, you're going to connect your local oscillator, and which is going to perform mixing, and this is going to be your RF signal. So these two guys are going to mix the signal, and IF is going to be the negative of that signal. So let me give you an idea. Let's say okay, the IF of this guy, I forgot the rating of the IF of this. The IF of this guy, let's say, is 455 megahertz. So what this will do, you will have a signal that is coming in from your antenna, which is going into your RF port, which says RF here. And then this local oscillator will generate another frequency, and you're going to add and subtract them. When you add them or subtract them, you're going to keep the subtracted frequency, and that subtracted frequency should be the frequency of IF, and this is further connected to the rest of the circuit. So this is a two-port device. Um, but in order to analyze this, you need to use three-port network, but we can also do it with two-port as well. There's a trick to it. Now, here's another two-port device. Another two-port device. One port is SMA male, and on the other side we have SMA female. This is actually an attenuator, and it's actually a 10 dB attenuator that actually brings the signal down to 10 dB. So, for example, where you have a signal requirement, you don't want to have um, uh, uh, a high signal, you just want to attenuate a signal, it will bring that signal down to 10 dB. So here is, you're going to use two-port analysis as well. Now here's a device which is actually known as quarter wave transformer, which was designed. So it's actually a quarter wave transformer, and this is also a two-port device which was locally designed and fabricated. This is also a two-port device. Okay, the thing about these three devices that I have available. This is a connector, this is an attenuator, this is a quarter wave transformer. These are passive devices. These are passive devices. You can connect it however you want. You can connect this side with this side with this, doesn't matter. But you cannot do that with an amplifier. See, in amplifier, you have two ports, which is your biasing, that you need to provide DC biasing. And here the DC biasing for this particular amplifier is 5 volts. And you cannot connect output to input to your output and output to your input. You cannot do that. So you need to make sure, okay, you just connect them as per the indication on the device. Same thing with your mixer as well. But these devices are passive devices. You can connect it however you want. It doesn't require extra power to actually run them. Uh, so I think I'm going to cut this video short. So we're going to continue with this in the next upcoming video.